But so now in the market we have a lot of demand in terms of the Spark and then Spark data science, Spark ML. So this is the reason. After HDFS, I am immediately going to start Spark. And again in the Spark we have different modules. But to start exploring and then writing the programs in the Spark. So there is Spark core and we have Spark SQL and we have Spark streams and then Spark ML and Spark integration with R, and then we have the Spark graph database. So typically for the data science folks, this 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 are mandatory, and in case you are people who are only looking for just the learning of Spark, for them this part is important. And core Spark, like basic Spark data processing that people are looking for them, core SQL streams, this is more than enough. And for the data science folks, this is very much focused, and because this is the core data science part. But when it comes to these three, why do we need to learn this? To program or to process data or to predict data. So whatever programs we are going to write, those programs we are going to utilize whatever programming we do in a basic core Spark programming. So that is the reason these two, and then this is important for the data science course. Core message, and then maybe these guys, maybe they can have some overview on ML and graph database. It is not at all required, but can still have some overview. People are only looking for Spark, okay, they can focus on this part. And before this Spark and Spark programs can be written on either Java, means whatever core or SQL stream. The entire stuff can be integrated with any programming API which is listed over here. I can use Java and I can use Scala and I can use Python. So here our focus would be on Scala, and we'll also discuss what are the limitations of going with these programs Scala, Python, Java. So, but we'll go with Scala, and also anyway, as for the data science folks, we'll also have a walkthrough on Python, and anyway, and after that I am going to R, and R also once we finish, because Spark, once you are comfortable on all these things, like getting into any other technology, it's a matter of couple of days, because by this time we'll have everything. And for this, whatever prerequisite before going to start ML part, I will go complete theoretical in your content, whatever statistical programming concepts are there. And before starting off ML, I am going to take care of the statistical programming part. So this is the agenda. People who are looking for the data science, okay, don't be under confusion. And whatever flow I am going to follow it. Now we'll quickly finish some basic HDFS commands. We already know the theory, architecture, and all that stuff. And the reason why I had to go it, because Spark is a distributed processing engine. So we must know some little bit of background. And then we'll start now Spark, course, SQL, and streams will have a lightweight overview. But for core Spark, people will go detail on this one. And we'll be using programming API Scala for all of them. And before starting of ML, we go in-depth understanding of what are the concept of statistical, that is your actual data science. But without this programming, we cannot go into, we will not understand to implement them. So that is the reason this is what I am following right now. Okay, so now to get quickly into HDFS, yesterday we detailed very much discussed about how the distribution works here. And when you have data, if you have multiple nodes, the first one is the local, which is your specific to your local system. And when you have HDFS installed, that is going to be the distributed, and then this can be scalable vertically to any number of or infinite number of nodes. And when you are referring to HDFS, and that is a single distributed file system for us. But when you are talking to the local, let's say this is a node 1, when you are talking to the local, and always we will be using the local file system, which is your hdfs or FAT32, something like this. Now, to start working with hdfs, and yesterday we already logged in and saw that. Okay, so right now I just logged into the system where I have the Linux operating system in place, and this is where we have a local file system. This is our local file system. And whatever I am talking about here is, this is all talks about existing file system, and currently we already explored about the Unix commands and all that. Okay, we already created the folder. And also we have seen, if you want to get some data to your local Unix system, you need to use in some FTP and all that. Say for example, now you have some other server, like a Windows server or something, or your laptop. From this laptop, if you want to get your files to be processed into your machine, you can just use any of the FTP. And these FTP commands are going to be place your data from your local system to your Windows or any other system to your local machine. And this we already saw yesterday, and we have some files here. So, and also we have seen the configuration files for every individual services which are going to run on your HDFS. And for HDFS site, map reduce, and then hive site, and for all of them we have a different configuration file. Maybe if you are administrator, you need to get into that site, otherwise not required. Now, how to get this, like how to check whether your Hadoop is running or not, and that is very easy. You have seen that commands already. Say now if you are looking for Hive, whether the Hive service is running or not, you can use it. And if you want to, if you are looking for HDFS, you can look for this. And this is how you can check whether Hadoop service is running or not. And Hadoop class path we have seen yesterday. It will tell you where your configuration and from where your system parcels, Cloudera parcels, or your libraries are trying to set to pick up from the backend. Typically, those are all your jar files. And now, from now onwards, we can talk about the file system commands. If you just simply type your Hadoop, and it will show you list of category of commands are supported from the Hadoop. Okay, we have seen version, we have seen class path, and daemon log. These are all for administration purpose. But to access from here, to access HDFS related or distributed file system related data, files or anything, we have a special utility called FS, and using this FS, and we are going to place the files or access the files, or we are going to deal with the files which are there on your HDFS system. So if you say HD, and there are a lot of commands available in Hadoop FS, because previously you have seen Hadoop class path and all, that is only the very high level. But by the moment by giving your Hadoop FS, and the FS stands for file system, you are going to write file system command. File system command means your distributed file system commands, and when you press it, you will get list of all the commands available in the file system, generally put, get, and copy, delete, and all those things. So basic things whatever required I am going to tell you now here. Okay, say for example, so now I have a file here, emp, and these all these files currently on the local file system, that is on my Windows. And if you see, the path of the system is home, Cloudera, DS. Similarly, when you install HDFS machine on your system, So the HDFS similarly, like how Linux, when we say in our Linux, the root, the file system always starts from the root. That is where your starting point or entry point in a local file system. That is your root. And similarly, when you have created your HDFS, maybe across n number of nodes you have created, the entire HDFS file system again here also will be started with the root. To access that, we can use, say for example, now I want to see what are the files we have in HDFS. So you can say hadoop fs, and then to support or to access the files which are our, generally ls is the command in the Linux, right? And similarly, we can use ls command, and your file system HDFS also starts from root only, and by giving your root, and this is going to give you the files which are there on your HDFS file system. And when I say ls, it is going to give on whichever machine you have connected, on that machine whatever root directory is. And if I connect here, if I use ls, it will give you list of files only on this node. But when you say fs, ls and your ls command, it is going to give across entire HDFS. It is going to be a single HDFS. So the, no matter internally your nodes and your data nodes or your data blocks are physically present in so many number of nodes, and this information is going to come. So from where it is going to come, it is not really going to the disk and all. We already know. So we will have a name node here. The moment when we say name node, whenever we say I want to look for some particular file, this is your actual distributed file system sitting on top of all the individual nodes. And but in this particular node, when you take, let's say, a.txt file, say for example, I have placed a.txt file on this HDFS. So the data blocks might be divided into n number of nodes, but the file name and the number of blocks and block addresses will be stored in a name node. So when you say hadoop fs ls and then some directory, it is going to show what are the files available in your HDFS. That information picked from the name node. It will not really go and search on the HDFS, it will pick it from the name node itself. So if you see in my, so currently if you look at, this is my file directory structure in my local system. So right now I am here, here have some files, already have some files here, but my directory structure, if you see here, it is like this. This is belongs to this. But if I go to another machine, I may also have the same directory structure in another system as well. Like this, you can have a number of. But when it comes to this is a single directory structure. If you see, I'm picking up one folder here, user, and this is going to be here. So this is the bigger one across all the nodes, and this is the local. So when you say that, and that is the reason yesterday I spoke about the local. Local means ls means it will talk about only this. Even it will not even talk about. When we say fs, it is going to talk about hdfs here. So in this user, I have some more files here, and that I am going to display using. So under this user directory, we have different folders here, and maybe under this I can have. So this is the home directory. So when we have once we have created Cloudera and once we have installed all the softwares on this machine, depends on your installation what we are doing. Those installations will automatically create these particular directories. If you have installed Hive on your system, it will create one folder on its own. The Hive installation itself will create this folder. Spark will create it and Woozy will create it, but this folder is created by me only. So me means like your Cloudera will be after installation of the Cloudera to have some specific location to store some data and then do something. And so that is the reason if you see this folder is created by a different user. When your software is getting installed on Cloudera, for every we have an option to choose a single user to install every software. That is from the administration point of view, or we can choose to use different users for different software. So Hive, like Cloudera recommends to use different users for all of them, because if you want to set different permissions and control them, that will become difficult if you use one single. So internally all these folders are created and managed by different users, you can see here. So these are all operating system users, and this user is now owned by Cloudera, the one which are right now logged in, and even during the installation also this is the user created by us, and this is for the map ready. So now under Cloudera, because this is the folder generally we are not supposed to touch these folders. Maybe you can touch it, but ideally these are all meant for software internal usage purpose, not to be disturbed. And but this you can do whatever you want. This is created especially for us. And even after creation of these folders, like we will see how to create a folder. And especially most of the times in interviews, people will talk about security, the senior folks. How do we implement security? Even for these folders, I can set the permissions. So for example, now there are 20 developers or 20 users and I have a folder. If I don't want to give access on this folder to some specific users, I can still set the permissions. But mostly depends on your organization or structure. We may think about the permissions and all this. Otherwise, it's up to you. Like how do you want to handle it? And these are the folders we have here. You can see. So this way, if you look at, if I am really looking at this file, when I say ls and search for this particular file, it may not be there because this is from the hdfs, and this file may not. This is simply the name is coming from the name node. It is because the file name is not on the disk. The file names are only in the name node. It is picking up from the name node. But in your distributed file system, you have the data and your blocks are there. The file names comes from here, and when you are accessing the data from that, it is going to pick from the data blocks. So all this information currently coming from the name node. So now, so this is a very basic simple command, hadoop fs ls will give you what are the size, what are the files we have and all that. And even if you use, there is an option. So this H will give you, as already discussed, okay, and this I am showing you just to give you. By default, ls of HDFS will give you the complete information which is equivalent to ls-l. So ls is equivalent to almost ls-l in Unix. And in case you want to set additional options to your command in HDFS, generally in Unix, what do we do? ls-h we can give. And similarly, if you want to give any options with ls, you can just give -h option like this. And in case you want to give, let's say for example, If you want to give some more additional options, and we cannot combine, if it is in a Unix, H and D or like H and R, all those things will be directly giving HD something like this. But in HDFS, any additional parameters to your command must be given with something like this. Not sure whether in this version this R is there or not. But the same thing, if I want to give in a Unix, I'll be just giving one after one. But in Unix, let's say if you want to give ls-lh or something like this, will be given. But in the whenever there are some additional parameters required for your ls, that will go something like this. Okay. So now I want to create some directory on HDFS. So first of all, always you need to find. It's not like you can go and sit on HDFS file system and explore. So always will be in our local file system, and from here we will be writing the commands here. And now to create ls, as usual, display, and if you want to create a directory on your HDFS system, you can create a directory by using mkdir option. And now you can see in our file, you will have a folder created under Cloudera. There is a file created. And when you, if you already, your folder is already present, if you try to create it, will warn you. And this information is going to be checked in your name node itself. And in case you want to just simply ignore this option, you can also see. Mostly here, basic level not important, but if you are using any MapReduce or any other programming, or if you are planning to do this, these options may help you. So icon V will prevent warning. Let's say in case if there are any errors, let's say your directory already there, so it will not make your command failure. It will simply ignore it. It is not like it is recreated the folder. Since it is already there, it is just simply making your command success, but internally it is not doing anything. So now mkdir and all that. So now if you want to place a file, so right now I have a file here. The file size is very minimal, and I am planning to place this emv file onto this particular machine, or this file onto this particular machine. To place a file onto your machine, we have a command called put. So put is actually influenced from a FTP command. Like in general FTP command, we have a put and get. So put always get a place a file from your local machine to your HDFS. So when you are placing HDFS, you need to mention to which folder you need to place here. So Adobe FS put whatever file you want, and then you can give a your directory name, and then it is going to place. And in case while placing your file, if you want to change a file name, if you give only folder name, it will directly place this file. And if you want to rename the file, you can simply give your target name here. Say for example, right now it is already placed. So again I am giving test.csv, and still it is possible. It will check the last one whether the directory or not, and now it is going to place it in a different way. So you can place a file as it is, or you can also place, or even you can place multiple files. So let's say if you have some 20 files, one way is let's file name, space file name, space file name, space file name. And if you want to give some place some files with wildcard pattern matching, you can say star dot something. All those will work over here. But the basic put command can help you to. Okay, so now we can see under this directory we have these two files available. This file and this file. And if you want to copy a file, it is a simple transferring of the file, and it is copying with the rename of your file. And anyway we know this. So now once you place the file, but what is the difference? So now I have a file, earlier I have a file here, cmb.txt, but now this file has been placed here. So now your data blocks have been like means your data now when you the moment when you place your file, it is going to be follow all your hdfs fundamentals rules we discussed actually. That is your distributed block size and all that is going to be followed when you place this file over here. So to prove that, but how this play, whether it is in one location or because we have a single node and then even file size is not even bigger. But if you want to, just if you are curious about to know, so this file on hdfs how it is placed. So I can give test file name or anything. But if I use one command like fsck, okay, this is a file system check command. Just for understanding purpose, you don't need to use it. This file, this particular file, whatever is placed on your hdfs, now we get to know how many number of blocks it is divided and what is the replication we had. All that information you can get it. So now you can see complete story about there is a file because when you see you can see this, but this name comes from the data sorry your name node because it is there and then it is displaying further. But if you want to really see the back how it is stored, now you can see this is your total size of your file and the number of directories because this is not a directory file, file one file and the total blocks. So for this particular file, how many number of blocks are divided? There is only single block created for this one because we don't have even size of more 128 MB. So absolutely one block only. And then average block size, that is nothing but your, because in case you have some 20 blocks and what is your block size? So why average block size will not be always 128? Because your last block may not be having 128 because always last block will be less than or equivalent to 128. So based on that it will create a average and minimally replicated blocks. So how many blocks are replicated? One block. And what is the replication factor? Since we have only one node here, so it is creating only one replication. Average block replication also one only here. And the number of data nodes one and the number of racks also one. So now even if you see, it is automatically identified how many racks you have in your installation. And if you have some n number of racks, because always Hadoop will follow the rack aware replication and for that it will initially use the basic information or we can also provide additional information about the clusters and racks and the administration level itself. And that way you can clearly see how it is. Say for example, now the block is the file is very smaller and we are able to put a like create a single block. So let me search for a bigger file. Yeah, I think there is one file. I need to place one file. Let me keep some data for that. Let me search for extreme file. That will be always so file. So it will take some time. So now I have a file. This I need to transfer to. Since I have access to my Cloudera graphical interface, so I can directly copy paste it. But as I already told, in case your file to be uploaded to your system, we need to follow FTP FileZilla, which I showed you. So anyway, you already know. I'm not going to do that. So this is your file. This I am going to copy into local machine. So I am going to Cloudera, but it is still your local only. So generally in real time you may not have access this kind of screen because you just be accessing through only your IP only. So in that case you have to transfer to FileZilla, which you have seen previously. So now I am going to data directory which was created there, and now we have a file here. The file size will be almost how much? Still getting. So this is one of the sample file of clickstream data. Yeah. So now this is a single file which is simply available here. The size is 598 MB. But the moment when I place this file, so now this is getting distributed into blocks, and with each size of 128 MB, and that we know where that 128 MB block size configuration is there. And since we do not have more than or multiple nodes, what happens? These blocks will be stored in a single node with in different sizes. But in case you have multiple nodes, these blocks are going to be distributed into different nodes. So right now it is going to split. What is the size? 598. 598 is going to be split into 128 plus 128 plus 128. Still one more. 512. Okay, then equal to 598 minus 512 plus 8. So this is the total block size. These are the blocks 1, 2, 3, 4, 5. 5 blocks will be supposed to be created, And all these 5 blocks, if we have 5 machines nodes separately, 1, 2, 3, 4, 5. But in case you have these blocks, like in case we have less number of nodes, so these blocks, right now we have only single machine. So all these blocks will be put onto hdfs on single machine only. And also we don't have any nodes to replicate it, and that will be working in a similar line. So now we have a file here. It is already placed. Now I am checking this file. Now you can see the total blocks 5, and the average block size is this much kilobyte, because not 128, because that is divided by something, and you can say no replication because we don't have multiple nodes here. The total size is this. So this will prove you that like how many number of blocks have been created for your file, and then you can quickly verify that all that information using a different command here. So that is how you can prove it, how your HDFS is different from the local. So now I have a single file here. When I go to file here, this is the single file. When I say ls, file is there. There also file is there. The difference is there. It is in a single system, but it is divided into blocks. Of course, we don't have more number of nodes. That's the reason all blocks are in one place. That is the main difference in HDFS. And in case you want to get a file from the hdfs to here, and now unfortunately if I try to sorry, first let me get a simple file here. We have the files over here. So there are a lot of command varieties, but I am not going to cover here. I can share you the videos of the big data classes. You can explore it if anyone interested. I'm just covering very basic things here, which are minimum for Spark and then the data science purpose. So now I want to get this file back to my system. So this, you can simply use a command get, and this get will get a file from your machine to current location. So when you are getting, what are the conditions apply? Since you are getting the data from HDFS, and the data will come from n number of blocks. So we don't have a limitation on the data size on HDFS, but since you are transferring your data from HDFS to your local, this is coming to your local, you should ensure that your local file system has the space to store that particular file. And because you may have some terabytes of the data, right now it is just transferred over here. But right now there are small files, we have the space also available, but the file on HDFS and file on local is completely different. This is specific to your local single node, and this is overall. So you have to ensure your spaces and all that. And in case you want to get multiple files and then combine, we have a command called get merge. Yes, if you have like 1, 2, 3 files in your HDFS, and all these 3 files you want to combine and place into a single file in your local, and you can use get merge. That will not required to learn right now. And fs put get, these are the basic things. And mkdir we already see. And if you want to display the content of the file, say for example, we have say test file, test file. So how we have cat command in your system, in the same way we have cat in your system. You can see it is just displaying the data. Similarly, tail also it will display the bottom 10 kilobytes of the data for us. In case you don't want the complete information, because it will be very tough to display. So now you can see from the last it is displaying some 10 kilobytes of the data. That is your tail. As always, it is good to get see this kind of information. Okay. Similarly, there are a lot of commands. If you just type, you get many more things. But the basic, these are the things we wanted. And for more detail, I can share you the commands. Or I'll just quickly, if you or anyone interested, but I can share you the video. Um, Change group is related to permissions. If you want to change the owner or group of a file in a HDFS, change mode changes the permission and means that you read, write, execute permission. This will change the owner and copy from local. It is equivalent to put command. Copy to local. It is equivalent to get command. Count will give you how many number of records you have in your file. CP will copy file. Create snapshot will create a snapshot of a file. Typically, what the snapshot does, whenever you have some particular file today and you have some data, by creating a snapshot, it will prevent changing the data of your current particular day till now, or by the time, as on the time when you have created a snapshot, whatever data is there in your blocks, it is going to be prevented and nobody can delete it. And after that, if you make some change, like you add, if you create one more snapshot, and as on the time when you create a snapshot, whatever data is there, you can get it. So that way it will prevent the data changes, and also it will help you to get a picture of as on the time what is the information you have here. So DFDU in the Unix also I show you the file system commands and all that. And expand, okay, okay, anyway we'll discuss it now. And get command, we know find command will search for the files. They're all security related. Get merge I already told you. LSMK, and this is a move command. And remove will see, at least we should know this is move directly. Set rep. So when you are placing the file, so right now I have placed a file and the default replication is something 1 or 2, 3. But in your hdfs site.xml file, whatever replication is mentioned, and as per that replication, it is going to create your blocks. Sorry, as per the replication number, your blocks are getting replicated. But in case you are looking a single file or a particular file to have a different replication. So now I am placing a file, and for that particular file, only for that particular file, I want to either increase or decrease the replication. For that you can use a setref command. Tail, already I showed you. Text will display. In case you have a compressed file on your HDFS machine, if you want to display them, it will display. Text Z will create a 0-byte file. It is equivalent to text command. So last I can show this remove directory. And then, so for example, now we are in HDFS. I have a directory. Now here I am creating one directory DAR1. So this is going to create a directory in DAR1 under DS level. And then I will create one dummy file. and under dir I am going to create one dummy file by using such step. So now we have a file address. So now if you want to remove this dir1, if you have a empty directory, by using rmdir you can just simply delete your directory. Okay, so this directory I am planning to delete. Okay. Now if I try to delete the dir1, it will throw a warning saying that your directory is not empty. So in this case, even I showed you in Unix as well, rm minus f and r. So R stands for recursively. In whatever directory you are selecting, in that directory, recursively whatever subdirectories, whatever files you have, everything it is going to clean, and F forcefully without your warning. So it is a useful command and at the same time very dangerous command, especially when you are using Spark or MapReduce. Always data will be stored in the form of folders, and in case you want to delete a folder to write something, and always you can use combination of F and R. So now it will delete it. And also when you delete any file or anything in hdfs, similar to recycle bin, and here also in hdfs we have something called trash. So it will go, this information will be sent to the trash folder. And once a time, if you want to clean up your trash, like clean up everything, so we have some command called expunge. This expunge will clean up if you have any information in your. So, okay. So this will clean up your the trash which is there on your machine. Okay, these are all the basic commands I want to touch upon because I'll be using them mostly. I want at least make directory, remove directory, and then creating some dummy directory and all that. Okay, so now maybe if you need more detail, I can share you my regular Hadoop class videos. You can go through it, but still at least this information prerequisite is okay. Well, mostly in Hadoop side, if you are going detail, there are a lot of other commands like archive. What is the detailed explanation of the create snapshot? These are all important things for us. You can explore it as per your convenience. So this is I am going to end with hdfs, okay, and I am no longer going to spend more on this one. So now, as just we discussed before the start of our session, so now we need to get into to start ML. At least we need some programming language which supports ML. But initially we are going to start with Spark, and in the Spark ML is the entire the module for statistical algorithm implementation and application. So that is the reason. First, we should have Spark core programming, and then SQL, little bit of streaming, that is optional for ML. For the core Spark people, it is very important. And then here we will be having your ML part. And initially I am going to start with Scala and how we use this programming and all that. And before start of ML, we will go all statistical. Already I explained. So now why only Spark? You can ask me like the many people. I forcefully enforce you to learn ML with Spark only, and you can ask me like why only Spark? Like why can't be R and Python also there? And if you ask me the compare and decide which is the better for us. And right now I am choosing Spark. I'll tell you the reason. And anyway, I am not going to leave you like we'll do complete walkthrough and R and Python also, so that you will get time. So ideally, if you see, Spark is a data processing engine which is almost a replacement to MapReduce, which completely does the data processing in a distributed manner and uses in-memory and then lot of modules and easy programming, lazy evaluation, programming language support, Scala and all that lot of things we can talk about. Performance wise it is very good and all that. And if you look at the Python is only a programming language, R also a programming language where they have very rich set of ML libraries, and the R is specially designed for ML only. The Python originally it was a programming language. Now later on lot of libraries added for the scientific SciPy, and then lot of things are NumPy for the numerical expressions and all that. Whereas Spark is not a programming language, it's an engine. But Spark programs can be written using Python, Java or Scala. So that way, by going to the Spark and with Python, with Scala, with Java, you can apply your machine learning algorithms. But if you go only Python without Spark, if you only go with Python, you know programming of the Python, you know how to implement ML, but that cannot be the distributed. R also cannot be the distributed. But with this approach, you will have both of them. You will have a core data processing that can help you to get into the core data processing side, and you can also use ML. So nowadays we are very much using them, and also it can help you to. It will support multiple programming languages. So that is the reason. First we are going with Spark and Scala, and anyway that can other programming also can definitely get onto that. Anyway, I'll give you overview on other R and then Python also. So this is the reason I have chosen Spark only for the ML. And earlier I used to first start with R and then get into the Spark and in a lighter manner. But now I am focusing more on Spark, ML, Scala, and then lighter onto the R and Python. So with your additional effort, you can get onto them automatically. That is the concept. So tomorrow we will get into the Spark and Scala, what is that programming, what are the fundamentals and how it works and all that, and then maybe in first we'll start with Scala programming fundamentals, and then we get into Core, Spark and SQL, and then slowly get into that. So that is my agenda right now, and I will stop it for today.